ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన NSR ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ NSR ఇంపల్స్.
Good morning, welcome back. Today we are going to study significance of negative sign. Significance of negative sign, right, in the equation to calculate energy of electron. What does that negative sign indicates? Right, to understand that, let us consider an atom. Let us consider an atom. So this is nucleus and electron is present here. Say electron is present here. Now, say this is nth orbit. Let us assume the orbit is nth orbit. So the energy of this electron, let us assume En, energy of electron in nth orbit. Let us assume this as the nth orbit. I have considered an atom where the electron is present in nth orbit. Let En be the energy of electron in nth orbit. Suppose, imagine that I have supplied energy to the electron, right? I have supplied energy of electron and say I have supplied enough energy so that it comes out of atom at a place, let us call infinity, from nth orbit to infinity. So what is the meaning of infinity here? Here if I see the electron, it is under the influence of nucleus. Between nucleus and electron there exists attraction force, because nucleus is positive charge, electron is negative charge. To remove the electron, I have to supply energy to overcome this nuclear attraction. Imagine that I have applied energy, I have moved the electron from this point to this point. This is the point where the nuclear attraction force is 0. Let us assume there is no nuclear attraction force. So I have applied this much amount of energy to a point where there is no nuclear attraction force. So here the electron is said to be a free electron. An electron which is not under the influence of any attraction force, we call it as free electron. That point we call it as infinity. Now, the energy of electron at infinity is considered as 0. So 0 is the energy associated with the electron at infinity. Infinity is the point where there is no nuclear attraction force. Imagine that the electron, reverse process, the electron is coming from infinity towards the nucleus. It is coming from the infinity towards the nucleus. As it moves from infinity towards the nucleus, it does some work. It does some work by spending its energy. What is the energy of electron? We consider it as 0. So as it does some work, its energy has to decrease. That means its energy must become less than 0. Less than 0 means negative, right? So the negative sign indicates that the electron is under the influence of nucleus. The electron is bound to the nucleus. So this is how you can explain the significance of negative sign. The negative sign indicates electron is under the influence of nuclear attraction force, right? And the maximum energy that is possible for electron must be 0. When this happens, if the electron is present at infinity, what is infinity here? It is a point where the electron is free from nuclear attraction force. So the maximum energy possible is 0. So if it is under the influence of nucleus, its energy must be negative. That means you have to apply that much amount of energy to overcome the nuclear attraction. So it may be near to the nucleus or little away from the nucleus. If it is very near to the nucleus, then the energy will be more negative. If it is a little away from the nucleus, then it will be less negative, but it definitely carries negative sign as long as it is under the influence of nucleus. So, the possible values 0 or negative, maximum value 0, that is at infinity. Infinity is the point where there is no nuclear attraction force. So, this is how you can explain why the energy of electron has a negative sign. This negative sign I am talking. Now, so already in the last class we have studied the energy of electron in electron volt. This is the energy. So, for hydrogen atom, Z equal to 1, and if it is N equal to 1, then E1H equal to minus 13.6 into 1 square by 1 square, that is minus 13.6 electron volt per atom. For second orbit electron, E2H, energy of electron in the second orbit of hydrogen atom. So, that is equal to minus 13.6 into 1 square by 2 square, which is equal to minus 13.6 by 4. So, this is minus 4 into 3, 12.4 electron volt per atom. If for n equal to 3, third orbit, E3H equal to minus 13.6 into 1 square by 3 square. This is equal to minus 13.6 by 9. 1.51 electron volt per atom. N equals to 4, E4H minus 13.6, 1 square by 4 square, minus 13.6 by 16. I think approximately you will get minus 0.84, minus 0.84, minus 13.6 by 16, 13.6 by 16, right. So on you can calculate. So, as you can see, as n value increases, the energy of electron becomes less negative. The energy of electron becomes less negative. That means energy of electron increases. So, small correction, this is 0.85. So, as n value increases, the energy of electron becomes less negative. In other words, the energy of electron increases. Now, I want to find the difference for hydrogen atom between successive energy levels E2 minus E1, E2 minus E1. So, E2 is minus 3.4, minus 3.4, minus of minus 13.6. Similarly, E3 minus E2, E3 minus E2, so that is minus 1.51 minus of minus 3.4. Similarly, E4 minus E3, that is minus 0.85 minus of minus 1.51. I think first one you will get around 10.2 plus 10.2 electron volt. Similarly, we can calculate this. So So if I calculate for the 3.4, 1.51, 9, so I think you'll get 8, 1.89. So this is 1.89 electron volt, and the next one, that is 1.51, 0.85, 11, 6, 14, 8, 6, 0.66 electron volt. So why we are calculating this? Let us try to understand few points. In an atoms here, as n value increases, the energy of electron becomes less and less negative. In simple language, the energy of electron increases. Here E2 minus E1, that means second energy level, first energy level. The energy difference between second energy level and first energy level of electron. 3 minus 2, same thing. Third energy level, second energy level. 4 minus 3, fourth energy level, third energy level. So we have calculated the energy difference between successive energy levels. As you can see, between 2 and 1 the difference is 10.2, between 3 and 2 1.9, the difference in energy decreases. Next, 4 and 3 it is 0.66, it further decreases. So the point to be noted is, as n value increases, the energy difference between successive energy levels decreases, or energy levels becomes closer and closer. So when you draw the hydrogen spectrum, you have to show considerable difference between first and second, then you have to draw a closer line, because between these two the energy difference is more compared to this. So when I draw the next line, it must be much closer, much closer. So the energy difference will not be constant or same between successive energy levels. So let us recollect few points regarding the energy of electron. Right. So first point, in the equation to calculate the energy of electron, there is a negative sign. The negative sign indicates that the electron is bound to the nucleus. The electron is under the influence of nucleus. So the maximum energy possible for the electron is 0, and that is at infinity. Infinity means it is a point where the nuclear attraction force is 0. Such electron we call it as free electron, and the maximum energy possessed by such an electron is considered as, is taken by default as 0. Right. Next, here the energy of electron can be more negative, less negative. If the electron is much closer to the nucleus, then it will be more negative. It is away from the nucleus, then it is less negative. That means as n value increases, energy of electron increases or become less negative. And the last point, just now we have studied, with increase in n value, the energy difference between successive energy levels decreases. Next, now let us calculate calculation of, say, wavelength, wave number, frequency and energy. Let us start with wavelength, frequency, energy, then we will see the Rydberg constant. Now, let us study the equations to calculate wave number and frequency first. So, what is the equation for energy of electron? Okay, let us consider like this. Okay, so consider this as a nucleus. So this is energy level N1, this is energy level N2, energy level N1, energy level N2. So the electron is jumping from N1 to N2. So the electron present here in N1 initially, say it absorbs a photon and gains energy and jumps from energy level N1 to N2. So initially what is the energy of electron? En1. So En equal to, if you see the equation, minus 2 pi square m k z square k square z square e power 4 n square h square. 2 pi square m k square z square e power 4 n square by h square. Here the element is same, so z will be constant. The variable whose value changes is n. Here we are assuming n1 to n2. So let us find En1. So you will get negative sign here. 2 pi square m k square e power 4 by h square into z square 1 by n1 square. Similarly, energy of electron in n2 orbit, let us assume n2, 2 pi square m k square e power 4 h square z square. See, this n has some number, like it's just an integer like 1 2 3 4 5 6. Here in general, to derive the general equation, I am assuming this orbit energy level or orbit as n1. It can be 1 2 3 4 like that. The higher n2 will be greater than n1 because we are assuming that electron jumps from lower energy level to higher. So if this is 1, say it can be 2 3 4 5 6 like that. If it is 2, it is 3 4 5 6 7 like that. In general, I am assuming it as n2 now. So here it absorbs a photon, energy of photon is equal to what? Corresponding to difference between energies of orbits, second orbit and first orbit, that is n2 and n1. So En2 minus En, right, gives the energy of absorbed photon. So how do you find energy of absorbed photon? Let us assume hc by lambda. Now what is En2? I have to substitute this equation. What is En1? I have to substitute this equation. In this, what I can take common? This one. So substituting the equations here, so what I will get is minus 2 pi square m k square e power 4 by h square into z square 1 by n2 square minus 1 by n1 square. I have taken this value as common. See this one. This is common for both. These are anyway constants. Z is atomic number. I am taking one single atom, so atomic number will be same. Now here you can see there is a negative sign. So what I can do, I can multiply with that negative sign inside. So hc by lambda equal to 2 pi square m k square e power 4 by h square into z square. Multiplying with negative sign, what I will get? 1 by n1 square minus n2 square. Multiplying negative sign inside. Right. Now I have to find the equation to calculate wavelength. So from this, what is 1 by lambda equal to? 2 pi square m k square e power 4 by h square. Send this hc other side, h into h square, h cube into c. H cube into c into z square 1 by n1 square minus 1 by n2 square. So multiplying this hc, taking this st to the denominator, h square into h is h cube. Now all these variables are constant. See, all these physical quantities are constant. 2 is constant, pi has a constant value, mass of electron is constant, k permittivity of medium 1 by 4 pi epsilon naught, that is also constant, charge of electron constant, Planck's constant, c has a constant value. So this is another constant which we call it as a Rydberg constant, or z square 1 by n1 square minus n2 square. So 1 by lambda is nothing but nu bar. So this is the equation I am talking about, where r is Rydberg constant. Two pi square m k square e power 4 h cube into c. So this is the equation to calculate wave number as well as 1 by lambda. So from this, let us see how to find frequency. So what is frequency equal to? Frequency equal to c by lambda. So multiply this equation with c, you will get the answer. So this is c into 1 by lambda equal to this. So what I will get is r c z square 1 by n1 square minus 1 by n2 square. Right. So r is Rydberg constant. Right. C is velocity of light. C is velocity of light, 3 into 10 power 10 centimeters per second. R is Rydberg constant 109677 centimeter inverse, where Z is atomic number. N1 lower energy level, N2 higher energy level. So if you simplify this, this is 1.1 approximately. 1.1 into 3 is approximately 3.3. 10 power 10, 1, 2, 3, 4, 5. Approximately 10 power 15 into z square 1 by n1 square minus 1 by n2 square second inverse or hertz. That is the equation to calculate frequency. Let us study calculation of energy of electron in terms of Rydberg constant. So how to calculate energy of electron equation? En equal to minus 2 pi square m k square z square e power 4 by n square h square 2 pi square m k square z square e power 4 by n square h square. So what I am doing is I will directly write, substitute Rydberg constant value, that is minus 2 pi square m k square e power 4 by h cube into c. Just I have substituted r value. So compare it with this, leftover is, and we have to write z square here by n square. So 2 pi square we have, m we have, k square e power 4. Here we have h cube, here we have h. So we have to multiply with h as well as c. Now it is balanced. So multiplying this with hc will give this. Now what is this? This is nothing but Rydberg constant. So energy of electron equal to minus RCH into Z square by N square. This is the equation for energy of electron in terms of R. R is nothing but Rydberg constant. So let us apply for hydrogen atom. So for hydrogen atom Z equal to 1. So energy of electron in nth orbit for hydrogen atom equal to minus RH, Rydberg constant for hydrogen CH into 1 square by n square. So this is how you can express energy of electron. Now let us see equation to calculate ionization energy. So what is ionization energy? It is the energy required to remove the valency electron, most loosely bound electron from neutral gaseous atom. So let us consider an atom. Let us consider this is the electron. It is present in energy level En. So you have to free the electron. That means you have to remove the electron. You have to free the electron to a place where there is nuclear, where there is no nuclear attraction. That is nothing but at infinity. That is the meaning of ionization. You have to completely remove the electron from the atom. So what is the energy of electron at infinity? Energy of electron at infinity is considered to be 0. So this difference we call it as ionization energy. Energy required to remove the outermost electron or most loosely bound electron from the neutral gaseous atom. This we call it as ionization energy. So how do you calculate this? Ionization energy equal to E infinity minus En. What is E infinity? Energy of electron at infinity, that is 0 minus En. So ionization energy is minus En, which is equal to minus into minus 13.6 into Z square by N square electron volt per atom. So ionization energy equal to plus 13.6 into Z square by N square electron volt per atom. So the next one is calculation of time period and calculation of orbital frequency. So what is time period? Now when electron revolves around the nucleus in circular path, the time taken for completion of one revolution. The time taken for completion of one revolution. So here time, distance or velocity equal to distance travelled per unit time. Velocity equal to distance travelled per unit time. From that equation what I will get? Time equal to distance by velocity. whose distance electron is revolving around the nucleus. It has to travel a distance equal to the circumference of the circle. So circumference of the circle, distance travelled by the electron is nothing but circumference of the circle, which is equal to 2 pi r by velocity of electron, that is v. Suppose if it is present in nth orbit in general, so radius of electron in nth orbit, velocity of electron in nth orbit. So substituting the values, what we get, t equal to 2 pi is constant into Rn, radius of electron in nth orbit, n square h square by 4 pi square m kz e square by 1 by Vn nh by 2 pi kz e square. So you can simplify this. 2 pi is cancelled. H cube 4 pi square m k square. So here you will get n cube by z square e power 4. So time period is proportional to n cube by z square. So if you substitute and simplify these values, if you substitute these values and simplify, time period equal to 1.5 into 10 power minus 16 into n cube by z square seconds. Similarly, you can calculate orbital frequency. So what is orbital frequency? Number of revolutions made by electron in unit time, that is 1 second. ఒక సెకండ్లో ఎన్ని రెవల్యూషన్స్ చేస్తుంది. టైం పీరియడ్ అంటే the time taken for completion of one revolution. So they are inversely proportional. ఒక సెకండ్లో ఎన్ని రెవల్యూషన్స్ చేస్తుంది అన్నది ఆర్బిటాల్ ఫ్రీక్వెన్సీ. నంబర్ ఆఫ్ రెవల్యూషన్స్ మేడ్ బై ద ఎలక్ట్రాన్ ఇన్ ఎ గివెన్ ఆర్బిట్ అరౌండ్ ద న్యూక్లియస్ ఇన్ 1 second. It is reciprocal of time period. So here itself we can write it is reciprocal of orbital frequency. Now from this you can directly write, or it is actually velocity by circumference. This is velocity by circumference, and if you simplify that you will get the answer. So here it is 4 pi square m k square e power 4 by h cube into z square by n cube. So orbital frequency is proportional to z square by n cube. So if you substitute and simplify, it will be around 6.66 into 10 power 15, I think, z square by n cube second inverse. So the next part is limitations of Bohr's theory. Limitations of Bohr's theory. The first one, Bohr's theory was able to explain the spectrum of single electron species, single electron systems. What is single electron system? The atoms are ions containing one electron, like hydrogen, helium plus Li plus 2, Be plus 3. They all contain only one electron, so they are called as single electron species. Bohr's theory was able to explain the spectrum of single electron species, single electron system, but fails to explain the multi-electron systems. That means the atoms are ions that contains 2 or more electrons. So Bohr's theory was unable to explain the spectrum of multi-electron species. Multi-electron atoms are ions. That is the drawback. Next, it fails to explain the fine spectrum of hydrogen. It fails to explain the fine spectrum of hydrogen. What is the spectrum of hydrogen? Right. So you will get lines like this, different lines in different regions starting from UV to IR. But when you observe these lines under high resolving spectroscope, when you observe these lines, so I am taking this particular line under high resolving spectroscope, it is found that it is not a single line, but it is a group of closely spaced lines. It consists of a single line consists of group of closely spaced lines. Once again, when you observe the line spectrum of hydrogen under highly resolving power, high resolving spectroscope, it is found that each line consists of group of closely spaced lines. That means it is not a single line, but it consists of a group of closely spaced lines. This spectrum we call it as fine spectrum of hydrogen. Right. So according to Bohr's theory, it should be a line, but when these lines are observed under high resolving spectroscope, it is found that it was not a single line, but group of many closely spaced lines. This group of lines or this spectrum we call it as fine spectrum of hydrogen, which was not explained by Bohr's theory. Next one, it fails to explain Zeeman effect. So when the spectral lines, when the hydrogen spectrum is recorded by applying in the presence of magnetic field, external magnetic field, it is found that these lines further split. They split further, they give 2 or more lines. So such splitting of spectral lines in the presence of magnetic field, external magnetic field, we call it as Zeeman effect. If you apply electric field, the splitting of spectral lines we call it as Stark effect. Bohr's theory was unable to explain Zeeman effect and Stark effect. What is Zeeman effect? Splitting of spectral lines in the presence of magnetic field, that is Zeeman effect. Splitting of spectral lines in the presence of electric field. So when you apply external field depending upon magnetic or electric field interaction, these lines further splits, and he couldn't explain what is the reason for the splitting, or simply couldn't explain Zeeman effect and Stark effect. Next, it contradicts with uncertainty principle. So what is uncertainty principle, etc., we'll study in the coming class, but the point here is Bohr's theory contradicts with uncertainty principle. For the timing, just remember that point. Right, I will explain the meaning of uncertainty principle later. Next, it couldn't explain the chemical bond formation, doesn't explain chemical bond formation. So let us recollect once again. The first one, Bohr's theory was able to explain the spectrum of single electron system, that means atoms or ions containing only one electrons, but fails to explain the spectrum of multi-electron atoms or ions. Bohr's theory fails to explain fine spectrum of hydrogen. So what is fine spectrum? When the spectrum of hydrogen is observed under high resolving spectroscope, it is found that each line consists of group of closely spaced lines, which we call it as fine spectrum. This theory fails to explain Zeeman effect and Stark effect. What is Zeeman effect? Splitting of spectral lines in the presence of magnetic field. What is Stark effect? Splitting of spectral lines in the presence of electric field. Fourth point, it contradicts with uncertainty principle. Fifth point, it fails to explain the chemical bond formation.